The last video you saw transportation models, and in this video we're going to deal with transshipment models. And just like the last video, we're going to talk about transshipment models without the fixed costs, and then we're going to add the fixed costs and make sure we know how to do them using those binary variables. So let's get started. So transshipment models are different from transportation models because they have warehouses. Now I want to make it clear, factories A, B, and C are purely supply nodes. Markets 1, 2, 3 are purely receiving or demand nodes. Whereas warehouse D, which is also warehouse 4, so D and 4 are the same warehouse, and E and 5 are the same warehouse, are both supply. They supply at D, and then the demand side is numbers of 4 and 5. So D and 4, E and 5 are the same. And so here you have transportation cost per unit. You have warehouse capacity, how much can actually flow through a warehouse, 300 units and 200 units. Here we have these spots as blank, which basically tells us we cannot transport from D to 4. There's no cost involved here. And sometimes you could have a cost involved. If you have processing fee, let's say you're sending something through warehouse D and there's a processing fee, let's say $5 per unit. Now that would be a warehouse cost at D4, right? Similarly, you don't have anything which goes from D to warehouse E or warehouse 5. So there's no warehouse to warehouse transactions here. So we just leave that blank. Okay, so we need to find the cheapest way to transport the goods from factory directly to the market or from factory to warehouse and then to market. So here are the units. We have A1 all the way to A5, right? So A1 to market 1 to market 2 to market 3, warehouse 4 and 5. That's given. B1 to B5, C1 to C5. Now with D, you have only D1, 2, and 3 because 4 and 5, there is no units to be transported there. So here is this thing. We minimize the costs. As you can say, we multiply the costs times the values. And then you have the supply side constraints, very, very similar to your transportation problem. Your supply side, you have 1,500. Now remember, warehouse is not a supply, it's just a pass-through, how much can pass through. So you have A's, anything sent out of A has to be less than 500, anything sent out of B has to be less than 600, anything sent out of C has to be less than 400. Now from D, you can get up to 300 can pass through, and E only 200 can pass through. So that takes, these constraints take care of that. Your demand side constraints pretty much are equal to constraints. You're adding D and E to 1, right? And then now you've got to add a transshipment node, which basically says anything going into D, anything coming into 1, right? Anything that comes into 1 has to, anything that comes into 4 has to leave 4 and nothing can stay there. So A4 plus B4 plus C4, all these things are coming into 4 and they leave through D as D1, D2, D3. So A4 plus B4 plus C4 is equal to D1 plus D2 plus D3. You move them all together, then you basically subtract D1, D2, D3 from A4, B4, and C4, and that'll be equal to 0. So whatever is incoming is equal to whatever is outgoing, and that becomes an inflow. And then you have the integrality constraints. So once you got this, let's talk about how to set it up in Excel. So the first step in Excel is to actually have the problem, and this is the problem you have. So let's go ahead and copy this here. And I'm going to delete this part. Let me just go ahead and remove that. Give me a minute. There we go. Let me delete this. So your total supply is going to be the sum of these 5 cells. And you can copy this down all the way right here. So copy all of it down. And your total demand market is going to be everything from these 5. And again, you copy this. Now remember, you copy this. You can go ahead and copy this all the way here. And your total cost. All right. So here we have, these are all numbers here. Okay. Your total cost is going to be the sum product of all these costs, comma, these costs. Okay, so this is your total cost. So now let's go to the optimization. Your objective here is to minimize your total cost. Your cells, your variables, are these entire set of variables, right? Now let's look at our constraints. The first set of constraints are all these constraints here. Factory, warehouse should be less than their capacity. So that's set, that's clear, that's same as your transportation problem. But now here we have these three. Just the market is equal to these values. You cannot say the warehouses are equal to those values, right? And then you've got to say everything coming out of warehouse D should be equal to everything. So everything going out of warehouse D should be equal to what's coming into warehouse 4, because they are the same warehouse. Similarly, everything going out of E should be equal to warehouse 5. So we've got those two. We also want to make sure that all these are integers. Assume non-negative is true. And we run the model. And there you go. So we are saying that you want factory A to send to market 3 and warehouse 4. Factory B sends to market 1 and 2, and then warehouse 4 again. Factory C sends directly to warehouse 3. Then warehouse 4 receives 300 and it sends it to market 2. And then finally, your warehouse E is not used. And that's pretty much this transshipment problem. So the next problem, of course, is transshipment with capacity. And transshipment with capacity right here, you essentially are adding a fixed cost. That is, these factories are not created, these warehouses are not there. If you are going to create a warehouse, you incur a fixed cost of $50,000 each, and then here are the fixed costs for factories. So just like we did for warehouses, for the transportation problem, we create 5 binary variables, 1 each for each factory and 1 for the warehouse, right? So everything else is the same except we have 2 more new binary variables here. And so you're minimizing your variable cost here plus your fixed cost. And then you have constraints, supply side constraints. Now remember, these warehouses, these factories here and these warehouses have to be built before you can actually send any values. Therefore, the capacity is 500 and you multiply it by A. If A is 1, then you can send up to 500 units. If A is 0, you cannot send any units out of A. Similarly, in warehouse, if E is 0, then E1 plus E2 plus E3 is less than or equal to 0, and therefore it doesn't send any units. And the rest of the constraints are pretty much the same. So let's go back to Excel. All right, so here we have the transshipment model, the inputs. So let's go ahead and copy and paste these values here. So let's go ahead. Here we have your capacity. Let's see whether we're going to build something. Right, so here we have this. Let me go ahead and put this here. And then we will have Here is the supply instead of capacity. I think supply is a better word than capacity. I have made some modifications. So there was a gap in the previous what you saw, and suddenly you see the colors have changed for the fixed cost and whether you should build or not. And that's because I wanted to make sure that this is linked to this. Otherwise, we forget that. So let's look at the supply. The supply is the sum of whatever's coming out of factory, right? And you need to know that, whatever is coming in. So that's, and then your demand or whatever is going into a market, you need to copy that. That's the sum of all this. And you want to go ahead and copy all of that, right? You also want to do your, whether you build or something and you multiply it by the capacity, this is your actual capacity. And you know that your supply is less than or equal to actual capacity. Your total cost is going to be the sum product of your variable cost multiplied by this, right, plus your fixed cost. And so your fixed cost will be this multiplied by this. Now you have to break it up into two, because if I had the fixed cost in H rather than I, you could have just added the whole thing. But since I didn't, you have to modify it here. Okay, and this is our objective function. This is essentially what we want to minimize, right? And so we're going to focus on minimizing this. So let's go to our solver objective, and we know we want to minimize cell C20. Our variables, as we know here, is essentially this entire from C12 all the way to H16. Our constraints are supply is less than actual capacity. You add that, we make sure that the market, these three values, is equal to these three. Make sure that you don't select the warehouses here. You are going to select these values and say they are integer, and of course whether to build or not, and that's binary. You also have to, and this is where I often use color coding, you have to ensure that these four, warehouse to warehouse, there is no movement or transportation of goods from warehouse to warehouse. So you've got to put a 0 there, okay? And finally, you have to say whatever is coming out of warehouse D should be equal to whatever is going, what is going into warehouse 4 should be coming out of warehouse D. And again, same thing, E and 5, inflow and outflow, should be the same. So if you've done all of that, you've done all the constraints, make sure engine here is non-negative, and we can run the model, which will get you your solution. Solution is don't build warehouses, just use your factories and go through with the problem. And with this, we finish transshipment and transshipment with capacity. And in the next lecture, we're just going to talk about distribution and methods of distribution. And finally, we'll have one more lecture of network design, where we take a merger. We'll look at single sourcing. We're not going to look at single sourcing here. We look at that when we do our mergers. Okay, so we have 2 more big lectures, and we'll go through that soon.